So in the previous video, we obtained the first simplex table. So in this table, Cj represent the profit contribution, the quantity Zj represent the total contribution. Okay, so from here we can see that the value of Zj is 0. So it means the profit gain is 0. So we will say that the solution is not optimal. Not optimal means the solution is not maximum. Also, Cj minus Zj, it represents the net profit, that is the profit gain minus profit given up. Any negative number in Cj minus Zj row would tell us that profit would decrease if the corresponding variable will be added to the solution. So, we will say that an optimal solution for an optimal solution optimal solution means it is maximum or minimum. We should have all Cj minus Zj less than equal to 0. But this is not the case in our solution. Here we can see that we have two values 40 and 50 which is more than 0. So what this 40 and 50 shows? This shows that increase per unit of entering the basic non-basic variable into the basis. It means if we enter the variable x2 into the basis, x2 is the non-basic variable, s1, s2 basic variable because these are initially in the solution. So this represents that if we enter the variable x2 into the solution, it will give us the profit of 50. Naturally, we all want to make as much profit as possible. So we enter a new variable x2. So here x2, this x2 will be the entering variable. Corresponding to the maximum value that we obtain here. Okay, so this column is called pivot column. How we got this pivot column? By selecting maximum of, which we obtain by maximum of these all four numbers. So maximum, this will give us pivot column. Now, since each basic feasible solution contains only two variables with non-zero values, one of the two basic variables s1 or s2 will have to leave the solution and become 0 because the variable x2 is entering. Okay, so for that we need to make one calculation which we denote by theta, that we call it as ratio. Okay, in this what we will do, we will divide this RHS quantity 40 by the coefficient in the pivot column by 2. So this will give us 20. Similarly, to obtain this quantity here, we divide this 120 by the coefficient in the pivot column. We cannot divide it by any other quantity, which gives us 40. If you remember, the first constraint represents the number of labor hours and second constraint represents the availability of clay. Now, what this 20 and 40 represent? This represent 40 represent that the material clay is available to make 40 cups, but 40 mugs. And this 20 represent we have enough labor to produce 20 mugs. Okay, but the thing is that even if we have the material, we cannot able to make mugs unless we have the labor. So out of these two, 20 and 40, we have to select the minimum. This maximum, we are restricted to manufacturing. We are able to make maximum of 20 mugs because of less labor hours. So in this case, this will become our pivot row. Okay, so this shows that this variable s1 will be the outgoing variable. variable. So in the next simplex table, the variable s1 is replaced by variable x2, while s2 will be there in the table. So now we will make the second simplex table. Okay, this table is similar to the one we obtained previously, but what is changed? These rows will be same. This okay. What is changed? In place of s1 we have x2. So let us write first, draw the basic one. Okay, first here okay. This one we write down the variables x1, x2, s1, s2. Here we are writing the quantity which is RHS. Here we are writing the basic variable. Now our basic variable is x2 and s1. On the top we are writing down the value of Cj. This is here 40, 50, 0, 0. Also here we'll write the value of Cj. The basic variable x2 is having value 50. So it will become 50 here, and for s1 the value is 0. So it will become 50. Now we need to calculate the first and the second row. For that, what we'll do to compute, first of all this variable x2 is entered, so we will obtain the value first. So to find this, what we will do, if we look here, x2 is the incoming variable, x1 is the outgoing variable. So in the pivot column, if we look at the point of intersection of pivot column and pivot row, it is 2. This is called as pivot. So to obtain the new row, what we have to do? We have to divide all of these elements by 2. That is the pivot number. Okay, we call it as a pivot number. So when we divide 1 by 2, it will become half, 1, half, 0 and 20. Let us write it down there. We got 1 over 2, that is half, 1, half, 0 and 20. We need to obtain this second row. Here it is S2, not S1, because S2 is already there now. Okay. To compute this new table value, we have to use the following rule. This rule says that new value is equal to old value in the row or old row values minus the corresponding coefficient in pivot column, which will be above or below the pivot number, multiply the corresponding new table value. Corresponding new table means this new table pivot row value. New table pivot row value. Now let's see how to calculate it. Suppose we want to calculate the value under this x1. So in this rule, if we apply for x1 we were calculating. So for this rule, old value row. So we are looking at this value. Check the position here. The number here, it is 4. It is 4 minus corresponding coefficient in the pivot column. This is the pivot column. The coefficient is 3. We are taking 3 because it's down. So 3 multiply corresponding new table pivot row value. This is new table and this is the pivot row value. because we are looking value here. So this is half. So we'll get the value here 5 over 2, which is 4 minus 3 over 2. So this number we will write here 5 over 2. Okay, similarly, if we have to calculate for x2, again we check here, it is 3. 3 minus corresponding coefficient in pivot column, which is here 3, into corresponding new table pivot row value. So this is new table. We are looking for value here. So 1. So this will give you 3 minus 3, C, which will come here. Now we look for S1. For S1, if we are looking here, we check the corresponding value. This is old row value, 0 minus corresponding pivot column. Here it is 3 into new one. This is half. So this will give you minus 3 over 2. That will come here. Similarly, for calculating for S2, what we will get? 1 minus, again, this number 3 into the new one. It is 0. That will give you 1. This is 1. So, if you, and similarly, we want RHS here. So for right hand side quantity, it is old number. It is 120 minus 3 into, it is 20. So 120 minus 60, that is 60. So we'll get here 60. If you observed, this number 3 is same for all the calculation. Okay, so what this 3 is the number which is below the pivot number. So this is 3 is same for all the calculation of this row. Okay, now we complete the simplex table, the second simplex table, by computing the values of Zj and Zj minus Cj. Okay, how we are calculating Zj? For calculating Zj over here, what we have to do? We have to multiply 50 with half, which will give you 25, and 0 with 5 by 2. That will give you 0, and add them. That will give you 25. So we'll get here 25. Similarly, to calculate here, it is 50 multiply 1. That is 50 plus 0 into 0. It will give you 50. For this quantity, we'll multiply 50 with half. 50 multiply half, that is 25. And 0 multiply minus 3 by 2, which is 0. That will give you 25. Comes here. And here 50 multiply 0, 0. 0 multiply 1, 0. It is 0. 50 multiply 20. It is 1000. So this 1000 represents the profit. Now next step is to calculate Cj minus Zj. Calculate Cj minus Zj. 40 minus 25. That is 15. 50 minus 50, which is 0. 0 minus 25, it is minus 25. 0 minus 0, which is 0. Now here we'll see that we have one positive value. Even though we have 0 and negative, but still one value is positive. So again, the solution is not optimal. So when solution is not optimal, it means if we replace the basic solution by variable x1, since this is the maximum, we will get a profit of 15 units. So this will become our pivot column, and here x1 will be the entering variable. Okay, now since x1 is entering, we have to check which variable should be removed, which should be